Welcome back. I'm Marcus, and today we're doing a full walkthrough on LeverUp, the Perpetuals exchange on Monad. I've got James from the LeverUp team with me. James, welcome.
Thanks for having me, Marcus.
So let's just start from the top. What actually is LeverUp? One sentence, no jargon.
LeverUp is a perpetuals exchange on Monad, where positions are settled at the protocol layer rather than through an external liquidity pool, with protocol value flowing back to traders rather than to outside capital providers.
Already there's something in there that most listeners won't have seen on another protocol's homepage. Protocol layer settlement. That's doing a lot of work in that sentence. Let's unpack it. But first, why does this need to exist? What's actually broken about the perp DEX model that LeverUp is trying to fix?
Fair question, and I'd push back slightly on broken. The existing model works. It's just structured around a specific set of trade-offs that don't fully align with trader interests. The conventional LP-based perp design has three structural constraints that keep coming up. First, open interest is bounded by how much capital is in the LP pool. When LPs are thin, position sizes get capped. Second, a meaningful portion of every fee a trader pays flows out to external liquidity providers as compensation for the capital they've put in. Third, LP appetite follows market conditions. After a bad week, LPs exit, and the protocol's capacity shrinks exactly when trading might want to peak. LeverUp was built around a different answer to the settlement problem.
Right, and I want to make sure we ground this for listeners who are newer to perps. When you say LP pool is the counterparty, what does that actually mean in practice?
When you go long on a typical LP-based perp DEX and that trade makes money, the payout is coming from the capital LPs deposited. The pool is on the other side of your trade. LPs earn a share of protocol fees as compensation for bearing that directional exposure across the entire book. It works. It's why it became the dominant model. But that arrangement requires LPs to be paid, which means part of every fee a trader generates is flowing out to an external group of capital providers.
Okay, so that's the problem. Now tell me how LeverUp solves it. What is the VMMV and how does it actually work?
The VMMV is the virtual market making vault. It's the core infrastructure that handles execution and settlement at the protocol layer. Instead of routing position settlement through a passive LP pool, the VMMV handles it directly. Positions are settled through LeverUp's protocol-managed virtual liquidity architecture.
But here's where I always want to push. If there's no LP pool, where does the money come from when a trader wins big?
That question gets asked a lot, and it points at something important in the architecture. The protocol manages settlement risk through its own risk parameters, not through a passive pool of external capital. Open interest scales with those risk parameters rather than with the size of an externally supplied LP pool. The capacity isn't defined by how much third-party capital happens to be deposited at any given moment. It's governed by the protocol's own risk controls.
So it's not a pooled counterparty model. It's protocol-level risk management.
Exactly, the settlement responsibility sits at the protocol layer, which changes three things simultaneously. Open interest isn't capped by LP TVL. Protocol value flows back into the trader ecosystem rather than to an external LP layer. And every position, metric, and protocol flow is on-chain and verifiable. Anyone can check how positions are priced, settled, and accounted for.
That last part is interesting. On-chain verifiability. Most protocols say that, and it's marketing. What does it actually mean for a trader using LeverUp today?
It means you can go on-chain and check, how is my position priced? What Oracle feed is being used? How does the settlement math work? There's no black box. The protocol's mechanism is visible at the contract level, not just described in a white paper.
Let's get into the asset layer because this is where it gets more complex. You've got LVUSD, LVMON, AnyCollateral, Can you walk through what each of these actually is and why they exist?
Sure, start with LVUSD. When a trader opens a position using USDC as collateral, the system mints an equivalent amount of LVUSD, that's the protocol's synthetic stablecoin. Your position is denominated and settled in LVUSD. If you win, you receive more LVUSD than you deposited. If you lose, the difference returns to the vault.
And what stops LVUSD from depegging? That's the first thing any DeFi native is going to ask.
LVUSD maintains its peg through a TWAP-anchored stability mechanism. When the peg drifts off, the protocol runs LV auctions to absorb and burn excess LVUSD supply. That mechanism is what lets the protocol operate without external liquidity providers while maintaining settlement integrity. It's not just assumed to stay stable, there's a specific active mechanism governing it.
Okay, LVMON. That's the equivalent for MON collateral.
Right, LVMON is a synthetic token that mirrors MON's role within the trading layer. Positions opened with MON as collateral are settled in LVMON according to the protocol's settlement mechanism. And eligible LVMON can be staked for variable rewards or used as supported collateral. The rewards vary with participation, vault activity, and current protocol settings, not a fixed number.
That variable qualifier matters. Why not just give a fixed APY like everyone else does?
Because fixed APY claims are usually marketing. The actual rewards depend on protocol activity, and that's going to fluctuate. Saying variable isn't a weakness, it's the accurate description of how staking yield works in a system that's tied to real protocol revenue rather than an inflationary emissions schedule.
Let's spend some time on AnyCollateral, because I think this is one of the more misunderstood features. Can you explain what it actually lets traders do?
AnyCollateral lets traders use any supported monad ecosystem token as trading margin without selling a single coin. You lock the token as margin, trade with it, and by default receive your PNL in the same token. The protocol handles the Oracle integration, settlement logic, and liquidation mechanics on the backend. The token team does nothing on their end, no tokenomics changes, no new contracts, no sell pressure on the underlying.
Why would a token team care about that? Why frame it that way?
Because integrating AnyCollateral means their token becomes productive capital in the LeverUp ecosystem without any friction for the project itself. Holders can use their tokens as margin. That creates trading activity, which creates protocol revenue, which flows back to LV and into the broader ecosystem. The loop is, more supported tokens means more trading activity, means more protocol revenue, means more value flowing back into the ecosystem that fed it.
But there's a real risk here that traders need to understand. What happens to a position when the collateral token itself drops in price?
This is critical, and it doesn't get explained clearly enough. Each supported token carries a collateral ratio, a CR, that reflects its liquidity and volatility profile. A token with a 70% CR contributes 70 cents of effective margin per dollar deposited, and the token's price movement creates an independent source of liquidation risk, separate from the perp position itself. So you're managing two risk vectors simultaneously, your position's PNL and the underlying collateral token's price. Traders need to monitor both.
So you could be right on the trade direction and still get liquidated if your collateral token drops enough.
Exactly, that's the dual liquidation risk that comes with AnyCollateral, and it's something every trader using those positions needs to understand before going in.
Let's talk about Oracle infrastructure, because this matters a lot for how prices are referenced and how liquidations happen. LeverUp uses Pyth Pro. What does that actually mean versus standard Pyth?
Pyth Pro is the institutional tier of Pyth's Oracle service. In measured testing on Monad Mainnet, BTC-USD, and ETH-USD pairs, Pyth Pro averaged 0.086 seconds of staleness versus 1.676 seconds for Pyth Core. That's a 19.5x improvement. And in 91.4% of samples, Pro had zero staleness. The on-chain price matched the live market at that exact moment.
Why does staleness matter in practice? Walk me through a scenario where this is the difference between a good outcome and a bad one.
The clearest case is liquidation. If the Oracle feed is showing a price from 1.5 to 2 seconds ago during a fast market move, you're getting liquidated against a stale price, one that doesn't reflect where the market actually is right now. That's the "I got liquidated on a wick that wasn't there" problem you hear traders complain about on other platforms. Pyth Pro running near zero staleness means liquidations reference current prices, not snapshots from a second or two ago.
And Monad's block times are fast enough to actually use that data.
That's the other half of the equation. Pyth Pro publishes updates at high cadence, but if your chain can't consume them fast enough, you lose the benefit at execution. Monad's block times are fast enough to consume Pyth Pro's feeds at close to their native publish rate. The chain keeps up with the Oracle, so the end-to-end trading experience actually reflects Pro's data quality rather than having it degraded by execution latency.
Okay, let's talk about LV. What does the token actually do, and how does it connect to protocol revenue?
LV is the protocol token. The connection to protocol activity runs through two mechanisms. Traders earn LV through the point system, trading activity generates points, and LV is emitted to point holders each epoch. Then holders participate through XLV and YLV.
Break those down.
XLV stakers receive applicable protocol fee incentives in USDC based on the protocol's distribution rules. YLV users receive XLV incentives generated when applicable protocol fees are used to buy LV on the open market and stake it into XLV, which increases the YLV to XLV conversion rate over time. And separately, under the current LVMON mechanism, applicable staking commission is routed through the stated LV buyback and burn mechanism, purchased on the open market and sent to the burn address.
So the token's value connection to protocol performance is meant to be explicit rather than just narrative.
That's the design intent. The mechanism is auditable. You can watch the buyback happen on-chain. It's not a "trust us, we're aligned" statement. The flows are observable. Whether that's compelling is something each holder evaluates against the actual numbers, but the structure is transparent.
And to be clear for listeners, this is not a guarantee of price appreciation. The mechanism routes revenue to buybacks. What the market does with that is a separate question.
Correct. Protocol incentive and buyback mechanisms follow current protocol settings and any applicable stability safeguards. The connection to protocol performance is real and auditable, but it doesn't remove market risk for LV holders.
Last section, let's zoom out to the market picture. What are the actual trading options on LeverUp? Assets leverage, what's available right now?
Crypto majors with leverage up to 1001x. RWA markets, gold, silver, equity indices, stock perps, and monad ecosystem tokens. The combination of those three market categories on one platform is part of what LeverUp is building toward as a broader DeFi layer on Monad, not just a narrow perp venue.
1001x leverage, that's not a typo. Who is that for?
It's for traders who understand exactly what they're doing with high leverage. At 1001x, a tiny adverse move wipes the position. The leverage parameter existing doesn't mean anyone is recommended to use it at maximum. It exists because the protocol can support it architecturally, and there's genuine demand for those options from experienced traders who know how to size positions accordingly.
Fair, and the broader thesis here, LeverUp positioning itself as a DeFi layer rather than just a perp venue. What does that actually mean?
Perps plus staking plus yield plus the infrastructure that makes Monad ecosystem tokens productive across all of it. AnyCollateral is a piece of that. It extends LeverUp's role from a trading venue into a capital efficiency layer for the ecosystem. The through line is that the protocol's economics should be aligned with its participants. No external LP layer capturing a portion of trader fees. No opaque fee structures. Core protocol flows on-chain and verifiable.
Let me try to summarize what we've covered today and give listeners the clean version. LeverUp is a perpetuals exchange on Monad built around a protocol-managed virtual liquidity system, the VMMV, where positions are settled at the protocol layer without an external LP pool. Open interest scales with protocol risk parameters, not LPTVL. Protocol value flows back into the trader ecosystem through the XLV, YLV, and buyback mechanisms. The asset layer has LVUSD for USDC collateralized positions, LVMON for MON collateralized positions, and AnyCollateral for Monad ecosystem tokens with dual liquidation risk traders need to understand. Oracle infrastructure runs on Pyth Pro, which addresses stale pricing risk during fast markets, and LV connects to protocol revenue through auditable on-chain mechanisms. Does that land correctly?
That's accurate. I'd add one thing. Every piece of that, every position, flow, and mechanism is verifiable on-chain. That's the foundation the rest of the design sits on.
James, thanks for walking through all of this. For listeners who want to go deeper, the full article is linked in the show notes, A1 in the LeverUp content series. You can also go straight to app, LeverUp, Zeiss. I'm Marcus, and I'll see you in the next one.
Thanks, Marcus.